Okay. Okay, so this is chapter 13, and we're just going to deal with the coordinate geometry, not the, the plane transformations. So 13.1 deals with representations of lines. So in this particular section, we're going to talk about what a coordinate system is. And we'll look at the three different types of lines that are in the coordinate plane. Also, we'll talk about measuring how quickly a line rises or falls, which is going to be the concept of a slope. Also, we'll talk about connections between oblique lines and slopes, and also slopes with parallel lines and with perpendicular lines. Also, we'll be finding the slope of a non-vertical line through 2 points, also write an equation of a line, given some attributes here. Okay, so what is a coordinate system? Okay. Okay. A coordinate system is nothing but a tool that's used to locate points. Okay. So here we're going to be dealing with a new branch of geometry, which is called coordinate geometry. So here we're going to be putting the fields of algebra and geometry together. Okay. Because in geometry, one of the fundamental things that we talk about in geometry are going to be points and lines and planes. All right, so here, this shows how the same point and line could appear using what they call coordinate geometry. So here we got a line in blue that says y equal -3x plus 6, and a point on that line where a is. And here are the coordinates for a, 3, -3. Okay. Now, the coordinate plane is sometimes known as the Cartesian plane. It is a plane that contains two perpendicular number lines. And here the horizontal number line is called the x-axis. The vertical number line is called the y-axis. And here their intersection is called the origin. Okay. So let me do this. Let me go here. I probably need to erase this and show you what a coordinate plane looks like. So here I've got two number lines, and they're perpendicular to each other. Okay, the horizontal number line that you see here, we call that the x-axis. And then the vertical number line is called the y-axis. Okay, and those two number lines, the x and the y-axis, intersect at a point, because it takes two points to make up a line to form a, well, no, two lines intersect at a point. So here, in this case, we call this the origin. Okay. So here, the axes, they serve as a reference for how far horizontally or how far vertically you are from the origin. And of course, the coordinate plane lets us prescribe a location of a point using two numbers called an ordered pair. Okay, so I'm drawing tick marks here to indicate how far and how left you can go on the x-axis. And then from here, we can either go up or down. So that point where A was, where we had -3, 3, no, 3, -3, yeah. That's considered to be an ordered pair. Okay, because that 3 is the x coordinate. The -3 is the y coordinate. So the first number is the x coordinate. The second number in the ordered pair is the y coordinate. Okay. And what that first number does, it tells you how far to the right or to the left you need to go on the x-axis. And then your y coordinate tells you how far you need to go up or down, or above or below that horizontal axis, or the x-axis. Okay. So let's say it had some points like this. Usually they label the x-axis as x and the y-axis as y. And also the x and the y-axis separate the plane into what they call quadrants. So the one in the upper right is quadrant 1. The one in the upper left is quadrant 2. In the lower left, we call that quadrant 3, and quadrant 4 is in the lower right. Okay. And in the first quadrant, your ordered pairs for x and for y are going to be positive because you're going to the right and then up. So your x and your y coordinates will be positive. Now for quadrant 2, your x coordinates will be negative. And then you're going up, so the y coordinate has to be positive. And then for quadrant 3, you're going to the left, and then you're going down to be in this quadrant. So the x and the y coordinate will be negative. And then finally for quadrant 4, you're going to the right and then down. So that means the x coordinate has to be positive, the y coordinate has to be negative. All right, so let's say we had ordered pairs like this. Point A has the coordinates 4 and 7. And I want to plot that particular point on the coordinate plane. So here, we always start at the origin. 4 is a positive 4, so that means we go to the right 1, 2, 3, 4. And 7 is positive, so we need to go up. 1, 2, 3, 4, 5, 6, 7. So that point would be right here. And usually we label that as point A. And for point B, let's say we had this, -3, 2. And if I want to plot that on the coordinate plane, I start at the origin. -3 is negative, so I go to the left 3, 1, 2, 3. And then 2 is positive, I go up 2. And draw that point and label this as B. And you can see point B is in the second quadrant, whereas point A is in the first. And then for point C, so we got -5, -6. And I want to plot that, I go to the left 5, start at the origin, go to the left 1, 2, 3, 4, 5, and down 6. And label that as C. Okay, also, let's see, 2, -3. I'm gonna do one that's in the fourth quadrant. So for such a point like 2, -3, if I want to plot that, I start at the origin, go to the right 2, since 2 is positive. 3, the -3, that's negative, so I go down 3. Draw that point. That'd be D. And then, let's say this one, E has 6, 0. Okay. Again, start at the origin. The 6 is positive, so we go to the right 6. Now, at 0, well, for 0, for your Y, you don't go up or down. So that means that this point will be on the x-axis. Okay. And I'll do one more of these. 0, -8. So here, x is 0, so we don't go to the left or to the right. But we do go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Label that as that. So here, point F is on the y-axis. Okay. All right, so that's how we plot points on a coordinate plane. Okay, any questions on plotting points? Okay, and this is just continuing what I just got through talking about. All right, let's look at the 3 types of lines. In the coordinate plane, there are 3 types of lines. One would be vertical, the other one is horizontal, and the third is oblique. Okay. And in the XY plane, we often interchange the terms ordered pair and point. Okay. So when we say points, we're dealing with an ordered pair. Okay. And it takes 2 points to determine a unique line. If 2 different points satisfying the equation of the line have been determined, then you can use a straight edge to draw the line through the 2 points, resulting in the graph of the equation. Okay. So now first we'll talk about what a vertical line is and what it looks like. Okay. Now if you notice here we have a table of a few solutions, xy, to the equation x is equal to 3. So in this case here, if I let x be 3, then that means that y can be any number of my choosing, okay? Because the x coordinate is always going to be 3 here because it does say x is equal to 3. So y can be anything I want it, like -1, 0, 1, and 2. Okay. And this is what the graph would look like for those ordered pairs. So here we do for 3, -1, we go to the right 3 and down 1. There's the point. For 3, 0, we go to the right 3, and that's on the x-axis. For 3, 1, to the right 3 and up 1. And for 3, 2, to the right 3 and up 2. You can see that those 4 points form a vertical line going straight up and down. Question. Okay. All right. Okay, so that's what the graph looks like. It forms a vertical line. Okay. And on the next slide is the equation of a vertical line, which is going to be the orange box that I'm going to provide. Here it is. So a vertical line has an equation of the form x is equal to a, and a will be some number. So if I let a represent any number, the graph of the equation x equals a is a vertical line that passes through the point a, comma, 0. Because a vertical line would be crossing the x-axis anyway. All right, questions on that? Okay, next we'll look at a, or the opposite of a vertical line, that's a horizontal line. So here, this is what the table looks like for that. And this is to the equation y is equal to 2. So for y being equal to 2, that means x can be any number that I choose. But here for that equation, y must be equal to 2. That y coordinate has to be 2. I can choose like -2 and 0 and 2 and 3. But here y has to be equal to 2. Okay. All right, so on the next slide that you'll see is the graph. So -2, 2 will be to the left 2 and up 2. 0, 2, we stay at 0 but go up 2. That points on the y-axis. 2, 2 would be to the right 2 and up 2. And 3, 2 will be to the right 3 and up 2. You can see those 4 points form a horizontal line going straight across. And notice that it crosses the y-axis there. Okay. So that leads us to this. That a horizontal line has the equation of the form y is equal to b. And b is going to be some number. Okay, and in the orange box, b is going to be any number. The graph of the equation y equals b is a horizontal line that passes through the point 0b. Okay, because a horizontal line always crosses the y-axis. All right, questions about a horizontal line and what it looks like. Okay, the third type is the oblique line. And when we're talking about an oblique line, we're going to talk about a line that's usually slanted. It's not going to be horizontal or vertical. It'll be a little bit slanted. In this case, let's say we had y equal 2x plus 1. Now here they selected values for x, like -1, 0, 1, and 2. And for each x value that we selected, we have to substitute those values in for x in this equation. Okay, so like x equal -1, we have to do 2 times -1. That'd be -2. And then -2 plus this 1 would give us this -1. Okay. And then for x equals 0, 2 times 0 is 0, plus 1 would be 1. Then for x equal 1, 2 times the 1, 2 times 1 will be 2, and 2 plus 1 will be 3. And then finally for 2, 2 times 2 will be 4, plus 1 will be 5. So these represent the ordered pairs for this equation, y equal 2x plus 1. And then we plot those on the coordinate plane. So for -1, 1, to the left 1 and down 1. 0, 1, we stay at 0, but go up 1. For x equals, for 1, 3, to the right 1 and up 3. And then for 2, 5, to the right 2 and up 5. So we connect those dots or those points, and that does form the straight line of y equal 2x plus 1. Notice that it is oblique because it's not a horizontal line, nor is it a vertical line. So this gives us the equation of an oblique line, which is, in this case, y equal mx plus b. And here m is not going to be equal to 0. And b is any real number. Okay. And for it to be oblique, it can't be vertical nor horizontal. Okay. So those are the 3 types of lines that we'll be dealing with in this section. Okay, any questions about that? Okay, now here's where we're going to be introducing you to slope. And this measures how quickly a line rises or falls. So here's the next slide. All right, the slope, and it's sometimes called the steepness of a line, is going to be the number of units the graph rises or falls vertically for every unit we move to the right in the same direction that we read from the number line, from left to right. And in these 2 figures here, as you can see, it determines the slope. We can determine the slope of a line from this particular graph. Like here, the one on the left, this is the graph of y equal 3x plus 1. If you go from left to right, you're going to run to the right 1 and then rise up. 1, 2, 3. And then from here, we can run to the right 1 and rise up 1, 2, 3. Okay, and we're going to talk about rise over run. So that means that the slope is going to be 3 over 1, or just 3. Now, the one on the right, this is the graph of y equal -2x plus 8. You can see this is falling from left to right, so that slope has to be negative. So from left to right, we run to the right 1 and go down 2. And then to the right 1 and down 2 again. So so that slope will be -2 over 1, or just -2. Okay. All right, now let's look at this particular problem here. And forgive me if that graph is not as clear in the slide. It says to determine the x-intercept, the y-intercept, and the slope of the line shown. And here I'm going to talk about what the x-intercept is and what the y-intercept is. Okay. All right, so this is what the graph looks like. And they did say determine the x-intercept, which I will write over here. All right, let me define what the x-intercept is. The x-intercept is going to be the point where this line crosses the x-axis. Okay. So in this case, this line crosses the x-axis at what point? Is it? Yes, 0, 3, because here's the x-axis right here. This line is crossing the x-axis at x equal 3. So the ordered pair, not 0, 3, what's the other way? 3, 0. Because x is 3, and we're not going up or down, so it'll be 3, 0. Okay. Questions on that? Okay. And now for the y-intercept. The y-intercept is the point where this line crosses the y-axis. So the 0, negative 6. Yeah, because it's below the horizontal axis, so it's negative. So 0, negative 6. Okay. And now they ask for the slope of the line shown. Now we're going to go from left to right on this. Because here's the point below that, below. And if I want to get to, let's say, this point right up here, I need to move up 1, 2, 3, 4, 5, 6. This is my rise, which is 6. And to get to that point from here, I need to run to the right 1, 2, 3. That's the run. In this case, it's going to be 3. Okay. So here, the slope is always going to be this, the rise divided by the run. I have to rise up 6 and run to the right 3. So that's 6 divided by 3, which is 2. That means that the slope of this line is 2. Okay. All right, any questions on that particular problem? Okay. Okay, let me give you the definition of a slope. Okay, and that would be this. If we have 2 points, x1, y1, and x2, y2, and they lie on a non-vertical line called L, then the slope of that line, L, would be this formula right here. The difference in your y coordinates, y2 minus y1, divided by the difference in your x coordinates, x2 minus x1. That's the formula we use to find the slope of any non-vertical line passing through 2 points. Okay. Notice that the vertical change is also called the rise. That's your y2 minus y1. the horizontal change is also called the run, and that would be x2 minus x1. Anyone has? Okay. All right, let's say I want to calculate the slope of the line through these 2 points, -4, 3 and 2, -5. -4, 3 and 2, -5. Okay, suppose I want to calculate the slope. And here we're going to use that slope formula. And that's m. That represents the slope. That's y2 minus y1 divided by x2 minus x1. And the way I would do that problem is this. The first point would be x1, y1 for those coordinates. The second point will have these coordinates, x2 and y2. That's how we'll label this. So here, y2 minus y1, that's a change in y2 and y1. That will be -5 minus 3. Divided by x2 minus x1. This is x2, that will be x1. 2 minus -4. And then we simplify the numerator and the denominator. So -5 minus 3, that's -8, divided by 2 minus a -4. That's the same as saying 2 plus 4. And that would be 6. And wherever possible, it would be best to reduce in simplest form. So -8/6 would reduce to -4/3. All right, any questions about that particular example that I just did? Okay, this is how they did it. Okay, now let's say we had these few problems here. Finding the slope of a line through the given points. Okay. All right, in this case here, I'm going to do these. I'll put these on the board for you all to see. All right, so this is part A, where we got 4, 3, and 0, 6. Now here we're just finding the slope of the line through those given points. Okay. So here, I'm gonna label that first point with the coordinates x1, y1, the second point with these coordinates x2 and y2. Okay. So the slope there would be y2 minus y1 divided by x2 minus x1 And in this case here, y2 minus y1, that's 6 minus 3, divided by x2 minus x1, 0 minus 4. And here, 6 minus 3, that's 3, over 0 minus 4, that's negative 4. This will end up being just negative 3/4 as the slope of the line going through those 2 points. Questions on part A. Now suppose you had something like this. Let's say 2, 7 and 7, 7. And we want to find the slope of that line going through those 2 points. Okay. So this will be x1, y1 for that first ordered pair, and x2, y2 for the second ordered pair. So the slope there would be y2 minus y1, 7 minus the 7, divided by x2 minus x1. Here x2 is 7, minus x1 is 2. So if I do 7 minus 7 in the numerator, that's 0. Over 7 minus 2, that would be 5. And 0 divided by 5, that's 0. All right, now anytime you have a slope of 0, that means that whatever this line is actually going to be a horizontal line. Because if you notice that your y coordinates are the same, that tells me that I'm going to have a horizontal line. Okay. Okay. Let's look at part C. Negative 2, 6 and 3, 8. So here, x1, y1 for the first ordered pair, x2, y2 for the second ordered pair. So that means here the slope would be, in this case, y2 minus y1. That's going to be 8 minus 6. And then divided by x2 minus x1, 3 minus a negative 2. So here, 8 minus 6 will be 2. And then 3 minus a negative 2, which would be 3 plus 2, which is 5. So the slope of that line through those 2 points would be just 2/5. Okay. All right, any questions about problem number 34 in the text? Because 0 minus 4, that's negative 4. Yeah.
So we did, as if I put it, I can put it, calculated as 3 divided by negative 4.
You just leave it as a fraction.
Oh, okay.
All right, any other questions? Okay. All right, now, problem number 41 on page 783 is a little bit different. Because then you're finding some number u such that a line through the point 2, 3 and 4 and some number u has a slope of each of the following. In part A, a slope of 5, part B, a slope of 0.2, and part C, a slope of negative 3. So we got the order pair 2, 3, and 4 with some number u, which is what we're trying to find. And in part A, we want to find out what that u is if we were given a slope of 5. So I'm going to say m is equal to 5. And of course, we use that slope formula, m is equal to y2 minus y1 divided by x2 minus x1. And of course, the 2 will be x1, 3 is y1, the 4 is x2, the u is what we're trying to find, that's going to be y2. So here, y2 minus y1, that's going to be this u minus 3. And of course, our m is going to be 5. So we substitute the m with 5 first. And then y2 would be u minus y1 would be 3. Divided by x2 minus x1, that would be 4 minus 2. So I'm going to have 5 is equal to, the numerator is u minus 3, the denominator 4 minus 2 would be 2. And you know what I'm going to do here? I'm going to put that 5 as 5 over 1. And then we're going to do a little cross multiplication here. This 5 cross multiplied with the 2 would give us 10. And that's equal to the 1 multiplied with the u minus 3 is u minus 3. And to solve for u, we're subtracting 3, so we have to add 3 to both sides. So u is equal to 13. So 13 has to represent the value of u in that second order pair so that the slope would be 5. All right, any questions on part A? Okay, now part B, we want to find out what u is so that the slope would be 0.2. Okay. So I'm still going to use that slope formula, m is equal to y2 minus y1 divided by x2 minus x1. Now this time our slope is 0.2, and that's going to be equal to y2 minus y1. That's u minus 3 divided by x2 minus x1, 4 minus 2. Okay. I'm going to put that 0.2 over 1. That'd be equal to u minus 3 over, or 4 minus 2, that would be 2. And then we're going to cross multiply. That 0.2 times 2, this is going to be 0.4. That's equal to 1 times u minus 3, which is, of course, u minus 3. And then to solve for u, we're subtracting 3. So we add 3 to both sides. That means u would be equal to, that'd be 3.4. So 3.4 would be the value of u, whereas the slope of that line would be 0.2. Oh, this says -3. Now, let's say the slope is -3, and I want to find out what the value of u was that would give me a slope of -3. Okay. So I'm still using the slope formula, m is equal to y2 minus y1 divided by x2 minus x1. So here m, that's -3, equals to y2 minus y1, u minus 3, divided by x2 minus x1, 4 minus 2. I'm gonna put that -3 over 1, and that's equal to u minus 3, divided by 4 minus 2, that's gonna be 2. And here I cross multiply. -3 times 2 will be -6, equals to 1 times u minus 3 will be u minus 3. And then we solve for u. We're subtracting 3, so we need to add 3 to both sides. So -3 will be the value of u such that I would get a slope of -3. Okay. All right, any questions about problem number 41 in the textbook? Okay. I tell you what, I will need to stop right here. Okay. So on Monday, we're finished with section 13.1 and start 13.2 on Monday as well. All right. And if you have yet to do exam number 3, I think that's due on Saturday. Okay, so make sure you have that done. Okay, and for those on Zoom, make sure your name is in the chat box. That way you'll be counted present. Okay, and you all have a good weekend. I'll see you Monday.